Dear student, till now we have elaborately discussed in detail the various preventive measures against corrosion. We have discussed three or four like that perhaps. Today we are going to discuss how we can control corrosion by modification of environment. If we carefully analyze, what does it mean? It means if any environment possesses some kind of corrosive ingredients, then corrosiveness of that environment can be controlled or monitored either by neutralizing the corrosive effect of the component responsible for that, or by discarding the corrosive component present in the environment. These are two possibilities. In this context, I would like to give you one example. Suppose in a classroom of 30 students, there is a student who is very, very disturbing, and he always makes nuisance in the class. And if I want to control him, I have two options in my account. Number one, the best option will be ask him to leave the class. This is called what? Expulsion. Second option will be, I will not ask him to leave the class. He will be there in the classroom itself, but he will not be able to make any nuisance. This is very similar to that one thing. As all of us know that in any environment, in terms of corrosiveness or in terms of corrosion, oxygen is considered to be the main culprit. And therefore we have to take care of oxygen. You know, we cannot survive without oxygen, but that very oxygen is very, very detrimental and very, very responsible for corrosion. And if we wish to control corrosion, we have to do something. And best option, if we succeed to expel oxygen from the environment, so automatically oxidation due to oxygen, that is chemical type, or in electrochemical type, absorption of oxygen type corrosion will be nullified. These two types of corrosion, possibility of these two types of corrosions will be nullified. And that is why I am telling you, corrosiveness of any environment can be monitored either by expelling or removing the corrosive component, or another option is there, or by adding something in the environment so that it will not behave corrosive, as it will be converted into non-corrosive component. And in doing so, we have four different steps, four different measures following which we can actually try to control corrosion. They are: number one, deaeration; number two, deactivation; number three, dehumidification; and number four, alkaline neutralization. These four different measures we have to control corrosion by modification of environment, and let us start with deaeration. All of you perhaps know it. The meaning of D is removal. Deaeration means removal of air. Actually, as I have told you a few minutes back, in a normal environment, oxygen is considered to be the main culprit as far as chemical type of corrosion due to oxygen or electrochemical type of corrosion, that is absorption of oxygen type corrosion, are concerned. And if we succeed to remove oxygen from the environment, automatically rate of corrosion will go down. And this is what is known as the aeration, because from any environment, oxygen cannot be removed as such, because oxygen is available in air in the form of a mechanical mixture. If we wish to remove oxygen, we have to remove air, and removal of air is known as deaeration, and therefore deaeration refers to removal of oxygen in the form of air. Now, how we can do that? For deaeration, what we can do, there are two ways. Number one is by setting a suitable temperature. And number two is mechanical agitation. Perhaps all of you know that. What happens during heating? As oxygen is present as a mechanical mixture, and if temperature is actually increased, the rate of diffusion of oxygen will be increased and it will go off. And because of that, availability of oxygen will become less and rate of corrosion will automatically go down. And this is the reason why we see reduced rate of corrosion in the pipeline carrying vapor concentrate, steam condensate from boiler. Steel pipe carrying steam from a boiler, in that case, because of high temperature, oxygen get evaporated or diffused out, as a result of which rate of corrosion goes down. So this is all about your deaeration. Now let us discuss about second one, and number two is the left mechanical agitation. You understand that? If you take a glass water test tube containing little bit of water, if you shake like that, this is called mechanical agitation. So in water oxygen is dissolved, as all of us know that. Generally in water 8 ml per liter of oxygen is dissolved. So if you shake it, because of agitation, some sort of energy will be produced, due to which solubility of oxygen will get reduced. As a result, it will go off, resulting reduced available oxygen, and therefore rate of corrosion can be controlled. This is what is known as mechanical agitation. Number two is deactivation. As I had told you earlier, there are two ways, either by expelling or by doing something so that the corrosive component will behave non-corrosive. This is known as deactivation. As we have seen earlier, oxygen is the main culprit. As we know that oxygen is a very good oxidizing agent, and therefore if we use calculated amount of reducing agent, so they will react together and producing non-corrosive compound, as a result of which availability of oxygen will be reduced, being consumed in the reaction, and rate of corrosion will go down. And to do that, we can use reducing agent like sodium sulfide, hydrazine. This compound may be used. If we use sodium sulfide, it will consume oxygen to produce Na2SO4. And similarly, if we use sodium sulfide, it also absorbs oxygen but react with oxygen to produce sodium sulfate. You see, oxygen get consumed in the reaction. As a result, presence of oxygen in the environment will be reduced. And similarly, hydrazine, you know that. Number 3, hydrazine, N2S4 plus oxygen, it will be producing nitrogen plus water, like this. This is all about deactivation. Here what we are doing, oxygen being an oxidizing agent, we are using suitable reducing agent and they will react together to produce non-corrosive compound, and thus the availability of oxygen will get reduced, automatically rate of corrosion will go down. Now let us discuss about third point, that is your dehumidification. You understand that? The removal of humidity. Humidity is moisture, you know that, water. As in organic chemistry, you might have seen, when water is removed, it is known as dehydration. It is known as dehumidification. What is dehumidification? You understand that. If water in the form of humidity is removed, because all of us know that water is a very, very important component in case of electrochemical type of corrosion. In majority cases, water plays the role of electrolyte. And therefore, if moisture, water in the form of moisture can be removed, removal of water in the form of moisture, but in the form of humidity, it is known as dehumidification. Your AC, air conditioned machine, it actually acts on the principle of dehumidification. But your cooler, air cooler, it acts just opposite to that principle. Water cooler acts on the principle of humidification, but AC on the principle of dehumidification. As all of us know that, if moisture can be removed, possibility of electrochemical cell will be reduced, and even if it is formed, intensity of corrosion will be less. In that situation, what we do? We generally use silica gel, heated alumina, what you have studied at 10+2 graduation level also, as a dehydrating agent. So if this compound are used, they will absorb moisture from the environment. Then if the environment becomes moisture free, no electrochemical cell will be produced due to absence of electrolyte. And even if moisture is there little bit, intensity of electrochemical reaction will be very, very mild. And now last one is your alkaline neutralization. As all of us know that majority of the environment are acidic in nature. In our earlier lecture I have discussed, wherever human beings live, there will be carbon dioxide in the environment. Other than carbon dioxide, sulfur dioxide, hydrogen sulfide, some other industrial gases may be there. All of them are acidic in nature, and therefore they will make your environment acidic. And therefore, in acidic situation, you know that release of hydrogen type mechanism is followed and corrosion proceeds. So if we can nullify or reduce the acidity of the environment and bring it back to almost neutral level, automatically rate of corrosion can be monitored. How we can do that? Calculated amount of ammonia or sodium hydroxide, if applied in an area in the form of spray, but we have to be very, very alert. We have to take calculated amount of, otherwise your environment will, if excess amount of base you take, your environment will become basic. Then another form of mechanism will be followed, and that is why we have to take calculated amount of ammonia or sodium hydroxide, so that your environment will become neutral. As a result, rate of corrosion will be controlled. And this process, that is alkaline neutralization, is extensively used to monitor or control corrosion in refinery equipment. And another thing I have forgot to tell you earlier, the concept of dehumidification is generally applied where AC, air conditioned machine, is used in a closed area, because dehumidification is not possible in an open area. So these are all about. These are 4 different options we have. These are all related to modification of environment, and by following this we can control corrosion remarkably. Please go through the video. I hope your concept will be clear. In case if there is any doubt, let us clear it in the next lecture.